So the ICSE Class 10 Physics Board exam is right around the corner, and the biggest question on everyone's mind is, what on earth should I be studying? Well, this right here is your strategic roadmap. It's designed to cut through all that noise and show you exactly where to focus your energy to get the highest marks possible.
And look, that's a totally fair question. It can feel, well, super overwhelming when you're staring at a huge syllabus. But don't you worry. The key isn't just to study hard, it's to study smart. And this guide, it's going to show you exactly how to do that. So, let's dive in.
First things first, we need a blueprint, a game plan. We're going to break down the entire syllabus by how many marks each section is worth. This is, without a doubt, the most important first step in planning your revision, because it tells you which chapters give you the biggest bang for your buck, the biggest return on your study time. And here it is. Take a look at this. You can immediately see the heavy hitters, right? The light unit and force, work and energy, are each potentially worth a whopping 25 marks. That's massive. Electricity and magnetism isn't far behind either. Just these three units together make up the bulk of your paper. This is where your focus needs to be.
Okay, let's kick things off with force, work, and energy. This unit is, well, it's foundational. If you can nail these concepts, you're really setting yourself up for success across the entire paper. Let's break down exactly what you've got to know.
So, inside the force chapter, there are 4 key areas you've got to lock down. First, moment of force and how to calculate it. Know that formula inside and out. Next, really get the concept of equilibrium, when all the forces and torques balance out, and have some good examples ready. The principle of moments is a classic exam topic, so don't skip it. And finally, for center of gravity, you pretty much just need to memorize the locations for different standard shapes. Now for the second half of this unit, for machines, you want to zoom in on mechanical advantage, velocity ratio, and especially pulley systems. Then, in the energy section, there are really only 2 main theories you need to master: the conservation of energy and the work-energy theorem. And listen, I can't say this enough. You absolutely positively have to practice the numerical problems for these energy concepts. That's where the real marks are hiding. Next up, our other heavyweight champion, light and sound. This section is all about waves, how they move, how they bend, and how we see and hear them. It's a really fascinating part of physics, so let's jump in and break down what you absolutely need to know.
Okay, for the light chapter, listen up. Diagrams are everything. I mean it. You have to be able to draw and explain normal and lateral shift perfectly. Then, get super comfortable with the lens formula and practice all the ray diagrams that go with it. Understanding deviation and dispersion in a prism, that's another topic that's pretty much guaranteed to show up. And finally, the electromagnetic spectrum. Just memorize the order, the key properties like wavelength, and maybe 1 or 2 uses for each wave.
Now, the sound chapter is a little more straightforward, which is nice. First, know your basic definitions: frequency, amplitude, speed, because these are perfect bait for those easy 1-mark questions. Next up is echoes, which all boils down to one simple formula. And finally, just make sure you can define and explain the conditions for forced vibrations. And this right here, this proves my point perfectly. The entire challenge of solving numericals on echoes comes down to this single formula. Speed equals 2 times the distance divided by time. If you understand this relationship, you can solve any echo problem they throw at you. It really is that simple.
All right, let's power through to our third major section. This one groups together some really important connected chapters: electricity, heat, and magnetism. This is where you really start to see how physics applies to the real world, which is pretty cool. Okay, when it comes to electricity, you start with the one thing that's totally non-negotiable: Ohm's law. After that, you need to spend a good chunk of time practicing circuit problems for series and parallel combinations. I'd almost bet money they'll be on the exam. Then you've got the practical stuff. Understand how a fuse works, the rules for sockets, and the logic of staircase wiring with that dual switch.
Let's keep this momentum going. In magnetism, you'll want to focus on the magnetic effect of current, what it depends on, and how to draw the field lines. Also, make sure you really get the structure and job of a transformer. Now for heat, it's all about one big topic: calorimetry. You have to master specific heat and latent heat, and you probably saw this coming, you have got to practice every single numerical problem you can get your hands on.
And here we are at our final deep dive, modern physics. Now, this section is all about radioactivity and the nucleus. It might not carry as many marks as the others, but the questions from here are usually pretty direct, which means they're easy marks, if you're prepared.
The whole game here is just getting the fundamentals right.
You start with the basics, the definitions, atomic number, mass number, and number of nucleons. Then, you learn the properties of alpha, beta, and gamma particles. Once you've got that, it's all about understanding how spitting out one of these particles changes the nucleus, what happens to the atomic and mass numbers, and how that moves the element around on the periodic table.
And to wrap this chapter up, you just need to do 2 more things. First, know the difference between nuclear fission and nuclear fusion. Know what they are, and memorize at least one example for each. And to finish it off, just be ready to talk about the safety precautions you need when you're dealing with anything radioactive.
Okay, so we've covered what to study. Now let's talk about the really important part, how you should study. Because your strategy should totally depend on what score you're aiming for. There is no one-size-fits-all plan here, so it's time to be honest with yourself about your goal.
This slide lays it out perfectly. There are 2 paths. Look, if you're aiming for a solid, very respectable 75 to 80%, your strategy is actually pretty simple. Focus only on the high-scoring topics we just went through, but master them, know them cold. Now, if you're aiming for the very top, we're talking 95% or higher. You can't afford to skip a single thing. You have to study the entire syllabus. Use this guide to decide what to study first, but make sure you eventually cover it all.
Just remember, everything you need, it's all right here. You have the roadmap. Your final exam can be brilliant. It really can. Just keep putting in that focused, smart work, and I promise you, you are going to see the results.
So, I'm going to leave you with one final thought. One question, really. You now have the complete blueprint for success. The only thing left to ask is, which of these high-scoring topics are you going to start mastering right now? Good luck and happy studying.